We introduce Wizualization, an immersive, situated, and ubiquitous analytics WebXR system that we liken to the fictional systems of magic that appear in fantasy novels, games, and films. Any number of devices, or arcane focuses, can be connected to a web browser room at optomancy.com, and interactions are propagated across arcane focuses via Weave, our signaling server. In this example, we're using a HoloLens 2 for mid-air gestures, and a smartphone for spoken commands. Once signaled, our rendering system, the eponymous Wizualization, matches the user's input with stored system commands, and generates a specification for Optomancy, the grammar we wrote for the system, and its React 3-fiber interpreter, Optomancy R3F, returns a React 3-fiber visualization component.
Color,
which is then rendered to the scene. Spellbook, our extended reality analytical notebook, presents the users with each step of their workflow as reflected within the element of the Optomancy grammar specification that has been updated by the spell that they've cast. Spellbook, in addition to returning spellblock React components to be rendered, also contains a number of basic pre-recorded spell primitives that we consider essential, which are shared across all rooms. These primitives each correspond to a spoken word in English, as well as a sign word in American Sign Language. Table 1 in the paper provides more detail on each individual primitive. Also shown on the left-hand side of Spellbook's menu interface, which, naturally, takes the form of a book. The right side of the book presents the user with a variable selection menu on the top, and a list of spell blocks on the bottom, which can be expanded for a stacked view or an unfolded view of each block. As a consequence of this means of linking devices, Wizualization supports synchronous collaboration within a room. In this example, 3 users, 1 remote and 2 co-located with each other, across 2 different countries are able to create and share views of the same dataset with each other in real time. We use this metaphor of magic in large part because the primary input modalities of mid-air gestures and spoken word, alongside that of direct manipulation with objects in the view, were both motivated by an assortment of magic systems. With that said, magic has influenced a number of our design decisions, such as the use of glowing particles to indicate that the user's hands are being tracked for input, or, of course, our naming conventions. Wizualization uses dynamic time warping to match users' gestures and Levenshtein edit distances to match spoken words or phrases, with recorded gestures and phrases stored either in Spellbook as gestural and spoken primitives, or persisting in Weave on an individual room basis. This allows for some error tolerance in matching the nearest word or gesture with the available commands.
axiom.
In this instance, the closest word to axiom is axis. If the user gets an unexpected system response, or finds that they're not interested in a step in their workflow, they can revert their view to an earlier state with a direct manipulation of a spellbook block.
So I've done a few accidental casts here. That one was on purpose, that was axis. So what I'll do is I will delete them, starting with this one. And that should set it back to a single axis with color.